I'll zoom. Okay. Let me redraw it. What is the length of this red line segment? Okay, I hear some answers. I've got 1, I've got 2. What else do you have? What else? Okay, these are the answers generated by you guys. Root 1. Okay, now I think some of you are changing your minds already. Who thinks the answer is 1 unit? 1 unit? Okay, nobody. How about 2 units? Still nobody. Half? 1/4? Square root 2? Okay, a lot. Square root 1? Okay, a few. How do we decide on the length of this line segment?
Must be a bit more than 1.
Must be a bit more than 1. Okay, this one is actually 1.4 something right. This is actually 1, right? Is it Pythagoras theorem? Is it Pythagoras theorem? Do I have a right angle triangle?
Yes.
You're right. What is this length over here?
1.
What is this length?
1.
What must this be? Okay? So the answer is square root 2. Let's try something more complicated. What is the length of this line segment? These are the options. The question was to find the length of the line segment. Let's do a quick recap. What do we do over here? We use Pythagoras, right? Simple. What about this one? Can I still draw a right angle triangle? It's over here, isn't it? And this is my right angle. Now to find the length of the line segment, it's again the hypotenuse. So it must be given by square root of A. I've got A and B used already, so you are referring to this length, right? And this length, isn't it? So what is the horizontal length?
4.
How do you get 4?
5
5 minus 1. Okay, so this is 4. So this must be 4 square, isn't it? Then plus, what is this length over here? 4 again, right? So 4 square. So this is correct. This gives us square root of 32. Is
So then for the 5.5741, right?
yeah.
I did Pythagoras theorem for the 2 and 1, then the 6 and 5.
Then wrong lah. What do you mean 2 and 1, 6 and 5? Oh wait. Were you trying to find the length over here, then the length over here, and then you minus?
Yeah.
But it is not. Your 0, A and B are not in a straight line, ma? You see, they actually form a triangle like this. So you made an assumption that 0, A and B were in a straight line, so you tried to minus. But they were not in a straight line. So that argument is flawed. Get it? Okay, so here we have, it seems like we are able to tell the length of a line segment. Let's try another one. This time a bit more complicated. Okay, Find the length of this line segment. So, and do you agree that this is what the right angle triangle should look like? Okay, what is the length over here? What is the length? 1. What is the length over here?
2.
So what must this length be? 2 square plus 1 square lah. Okay, square root 5. Okay? No, doesn't matter whether I've got negative numbers, positive numbers, as long as you can find the difference between two numbers, you can do it already. Okay? Now, let's check. How do you get 1 over here? How do you get 1? Negative 1 minus negative 2. You see, when you want to find a difference, right? You take bigger number minus smaller number or smaller number minus bigger minus smaller. Which one is bigger, which one is smaller? So negative 1 minus negative 1 minus negative 2. Bigger minus smaller we get? What do you get? 1. Then what about this over here? How do we get 2? 1 minus negative 1 to get us 2. Okay? So this is how we solve and how we get the values for the length of the line segment. So next, if I were to tell you, find the length of AB, where A is actually negative 3 and 4, B is maybe 2 and negative 8. How to find the length of this line segment? X values and the Y values. So these are my X values and these are my Y values, right? So compare X value minus X value. Big X minus small x, what do we get?
Y square.
2 minus negative 3. And then I square it. Yes? Then plus or minus? Plus. Next.
4 minus
Square. And I get square root of 5 square, which is 25, plus 12 square, 144, which is 13. Right? 13 units. This is how we find the length of a line segment. Now if you look at your textbook, they have a very similar introduction, but they give you this formula. Okay? Your choice whether you want to follow this formula or not. The thing about this formula is that it appears that the order matters. So let me just show you. They gave you A and B. Then they are expecting you to choose A as x1 and y1, B as x2, y2. Then the formula goes like this. x2 minus x1 square, y2 minus y1 square. It appears that they want you to do it exactly this way, but I didn't teach you that. Okay? Why? Because does it make a difference whether I write it this way or x1 minus x2 square plus y1 minus y2 square? Is there a difference in the final answer?
No.
Why no difference?
Because it's square.
Yeah. So this part, if it is positive, it will be positive. So if this is positive, this must be negative. But when I square, I get back the same answer, isn't it?
Yes.
And that is the reason. Now, how about this way? I've got x2 minus x1, y2 minus y1. Then I got x1 minus x2, y1 minus y2. What if I switch this one around? y2 minus y1. So I have 1 and 2, then 2 and 1. Does it make a difference
Yes.
in the final value?
No.
Yeah, it doesn't make a difference. So as long as you understand the logic behind it, you are not bounded by this formula. Understand what I'm saying? It is up to you. As long as you can tell me the difference in horizontal length, the difference in vertical length, you square both of them, you add them up, you square root, you get the answer. Can already. Alright, so let's do some quick examples. Okay, example number 2. This is example 2. No, not this one. Try it 1. Part A. I don't need to do part B, just part A. Find the length of PQ, QR, and PR. Just